All right, so since I'm not in class with you today, I thought I would give you just a quick warm-up and an overview of how far we've come when it comes to nomenclature this semester in chemistry. So here's a flow chart that basically summarizes all of the rules that you need to know in order to master nomenclature. So first we begin over here with all compounds. So when you're looking at the compound itself, you should first identify whether it is composed of simply 2 elements, which would make it a binary compound, or 3 or more elements, in which case it's a ternary compound and we're going to have to use those nasty polyatomic ions. Right? So let's take a look at the binary compounds. So the binary compounds, they can either be a metal with a nonmetal, and if it's a metal with a nonmetal, that's where we're going to use our crossover rule. And we're also going to reduce to lowest terms. Now, this also applies to our ternary compounds because the ones that we're looking at are also ionic because they contain ions, and we're also going to use the crossover rule and reduce those to lowest terms. Now let's carry on with our metal-nonmetal binary compounds. Right, so we have the choice of monovalent metal or multivalent metal as possibilities in our binary compounds. And so if it's a multivalent metal, we need to be especially careful to include Roman numerals or Latin names and prefixes and suffixes in order to adequately describe the ionic charge of our metal. But we're never going to do that with our monovalent metals because, of course, they only have one possible charge. So that charge is clear already simply by stating the name of the metal ion. Now, these rules, though, we need to remember also apply to our ternary compounds. If we see in our ternary ionic compounds that the metal is multivalent, we're also going to apply these rules to them. All right, let's try a few examples to get us started and to refresh our memory. So if you would like, grab a whiteboard and a whiteboard marker, and we will try a few examples out together. All right, so here I have a few examples for us to take a look at. And let's start with the first one. So let's maybe pause the video and give you a chance to try out these 3 different examples and see how you do. And then I'll go through them one by one to explain them so that you can make sense of them. All right, so let's zoom in and start the first example here. And so let me just make this a little finer. There we go. That's good. So when I look at this compound, I'm looking at the 2 elements that are making it up. So, you know, I have phosphorus, which is a nonmetal, and along with fluorine, which is also a nonmetal. So this is the time where I'm going to use the rules that apply to metal-nonmetal compounds. And so this is where I'm going to use my prefixes. So I have 1 phosphorus atom, so phosphorus. And I see that I have 5 fluorine atoms in this molecule. So phosphorus penta, remember penta is the prefix that I use when I have 5. So phosphorus pentafluoride. All right, let's take a look at the next example. So the next example that we have is CuCl2. So in this case, I can see right away that I have a metal and a nonmetal, and it's a binary compound. And so the metal I want to look very closely at, and I see that it's copper, and copper happens to be multivalent, which means that I'm going to have a couple of choices here. I'm going to either want to use Roman numerals or Latin prefixes. So let's break this down a little bit. So I know that copper can have 2 charges. So it can either be copper with a +1 charge or copper with a 2+ charge. And so in this compound, I need to figure out which one of those 2 it contains. Chloride, the chloride ion, always has a -1 charge in these ionic compounds. And so I can see really quickly that if I cross down this 2 from the copper and the -1 charge on chlorine, that will give me the formula that I'm looking for. And so that helps me name it appropriately. This compound is copper 2 chloride. And I'm not going to be able to fit that in, folks, but there we go. Another name for it is cupric chloride. So the the IC ending is what we give when the metal ion that is in a formula is the lower of the two possible charges. All right, next example. So next I have AgNO3. And so AgNO3, I can see really quickly, is not a binary compound. It has some silver, it has nitrogen, it has oxygen. It is a ternary compound. And so that should be my cue to go and take a look at my polyatomic ion chart. Now, I also have silver in here, and silver is a metal, but it's a monovalent metal, so I don't need to use any Roman numerals. This is just straight up silver, not silver 1. That would be incorrect. And then on my chart, I see that this NO3 business here has a name, and it is nitrate. So the name of this compound is just simply silver nitrate. Okay, and again, that's different than nitride. Nitride would only be would tell me that this compound contains the nitrogen atom only, not the nitrate ion. And so I need to be careful about my endings now. Hopefully you're doing okay so far. Now I'm going to move on to some examples where I'm going to get you to give me the formula. So if need be, pause this video to give yourself a chance to attempt to name these particular compounds, and then begin when you're ready to take them up. All right, so I'm going to zoom in on this first compound here, calcium acetate. And so I can tell right away that this acetate, it's on my list of polyatomic ions, so I'm going to need to look up its formula on my chart. So calcium as an ion from my periodic table has a +2 charge. And acetate as a polyatomic ion has the formula C2H3O2 with an overall -1 charge. And so what I'm going to do is I'm going to put brackets around my polyatomic ion, because when I do my crossover rule, this 2 from calcium is going to cross down and go outside of those brackets and apply to my entire polyatomic ion. And so this -1 that's on my acetate ion is going to get crossed down below my calcium. So the formula that results from this is calcium bracket C2H3O2 bracket and then the 2. Hopefully you did okay with that. Let's try another one. All right, so Auric Phosphate. So Auric is a Latin name, and that Latin name is for gold, and gold has the symbol Au. Now the ending IEC, is telling me that this is the gold ion with the higher of its two possible charges, and on the periodic table I look to see, and gold has a +3 charge. And that's the one that with the higher of the two charges. Otherwise, it would be gold with a +1 charge. Now, I also have phosphate, and I want to be careful here. This 8 ending is what's telling me there's not just a phosphorus atom. Otherwise, it would be called phosphide. The 8 ending is what lets me know that this is a polyatomic ion, and I'm going to call it PO4. 3-. That's what my chart tells me to say. I'm going to put my bracket around my polyatomic ion, and then I'm going to take my charges and cross them down. When I go ahead and do that, the resulting formula is AU3 bracket PO4 bracket 3. But now I'm going to stop for a minute and remind myself that this is still an ionic compound. And the fact that there's a 3 here and a 3 here indicates that the ratio of gold to phosphate ions is 3 to 3. And since it's ionic, I need to reduce that into lowest terms. And so a 3 and a 3 reduces to a 1 and 1 to 1 ratio. And so I'm simply going to write AuPO4. Now some of you may have written the brackets here and put a 1 outside, and that's fine. Typically we won't see that as a format. If there's a value other than a number higher than 1, then we would keep that. But if 1 is there, then we typically don't write it. We just leave it out, and we don't write the brackets because they're not necessary. All right, next and final example. Oh, nope, sorry about that. One more example after this. To finish off, Stannous Nitride. All right, so again, I have a Latin name here, and so the Latin name with the OUS ending tells me it's the lower of the 2 possible charges for my metal. Stannous tells me that it's the tin with the lower of its 2 possible charges, which in this case is tin with a 2+ charge. Now, nitride, the "ide" ending, is what tells me that it's not nitrate, it's plain old nitrogen. Now, nitrogen forms ions that will have a 3 negative charge. So I'm going to cross my charges down, and that's going to give me the resulting formula SN3N2. All right, one final example before I let you work on your worksheets today, and that is Xenon Heptafluoride. So I'm not sure if that was on our list initially. If it wasn't, maybe pause the video and give it a try on your own before moving on. All right, I'm going to take up this formula. So xenon is a nonmetal, and so is fluorine. And this hepta here reminds me, that prefix reminds me that this is a molecular compound, and that's why that prefix is there, because it's telling me a little bit about the number of fluoride ions in this compound. So xenon is all on its own. And that's what's telling me there's 1 of them. Otherwise, it would be dixenon or trixenon and so on and so forth. The heptafluoride tells me that it's fluoride, but hepta is a prefix referring to 7 atoms, and so I finish this off by just including that 7 as a subscript beside fluorine. All right, so not sure how you made out today. If you're needing some extra help, make sure you come in at lunch and get the extra help that you need. I'm happy to support you. Otherwise, rely on your peers to help you out as well and sort it out for yourselves. Just a reminder, there will be a quiz on all of chemical nomenclature on Monday.